Right, question 11. Name the constituent of an atom which has zero charge. Well, protons are +1, electrons are -1, so it has to be the neutron. Part 2 has the largest charge to mass ratio. So we're looking at something that has charge, so it can't be a neutron, it's got to be a proton or an electron. The magnitude of the charge on an electron is the same as the magnitude of a charge on a proton. One's negative, one's positive, obviously. But the electron's mass is much smaller, so that gives it a much bigger charge to mass ratio. The answer is electron. Part 3. Something which, when removed, leaves a different isotope of the element. Well, an isotope is the same atomic number, the same number of protons, but a different number of neutrons. So again, if I remove or add a neutron, that's what's going to turn it into an isotope. Part B, we're given a simple equation here. Thorium-229 going to radon something or other, and we're told that it goes via alpha decay. Remember, with alpha, we're basically going to lose 4 nucleons, 2 protons and 2 neutrons. So that means we're also going to lose 2 protons down here and 2 neutrons at the top. 4 because it's neutrons plus protons. So the new values of x and y. Well, x over here is the atomic mass number. That's going to decrease by 4. So that's 229 minus 4, 225. Y, that is the proton number, and that's going to go down by 2. Remember, an alpha particle is simply 2 neutrons, 2 protons, so that means that's going to go to 88. Part 2, we need to work out the ratio of the mass of the radium nucleus and, the mass of an alpha particle. So the mass, and we're not interested in the electrons, it says in the question, it's only the nucleus. The mass is going to be 225 for the radium nucleus, and the mass of the alpha particle is simply 4. You don't need to put the indices times 10 to the whatever because it's just a ratio, so as long as we're in the same units, they will cancel out, and that'll give us an answer of about 56.3. No units because it's dimensionless, it's just a ratio.